Okay, our next presentation comes from Martin Callaghan from Red Oak Consulting.
Yeah, that'll do. Okay, excellent. So, thanks very much. So my name's Martin Callaghan. I'm a principal consultant at Red Oak Consulting. Start off with a little bit about me. So I'm a consultant at Red Oak. I was previously an academic at the University of Leeds, and prior to that, HPC manager. Prior to that, a research software engineer. And prior to that, I was a teacher. I worked in further education for some 20 odd years, and even a few other careers prior to that. So I'm sort of reaching the late afternoon of my working life. I think that's the best way of putting it. And I think some of that sort of personally underpins what I'm going to talk about. This morning. I'll mention a little bit about Red Oak. I think quite a lot of people here will at least have heard of Red Oak, but we're a specialised HPC, AI and cloud consultancy with loads and loads of university, public sector and private sector customers. Well, we know there's a skills gap, and I think for particularly companies like Red Oak, and I'm sure some of the other companies that are represented here, we really struggle to recruit people. And we struggle to recruit people with the right skills and often the right mindset of skills. So there's not only a skills gap, but there's a sort of pipeline gap as well. And that's something that we want to try and work on, we want to try and address. So just as a matter of interest, who in the room is involved in student education in any way, shape or form, whether they're an academic, a lecturer, a teaching assistant? Good, about half of you. And about how many of you are students? Just as a matter of interest, have we got any students in the room? Just one. Oh, thank you for being here. There we go. So essentially, we want to try and encourage more graduates into our field. And really that means more employees, more people with the right skills, both for us and for you. And just coming back to that pipeline thing. So I'm sort of looking across the room here, and very many of us are of a certain age and a certain gender. And I think that is a fairly major issue that again underpins this, and I'm really glad that our previous speaker spoke quite at length about diversity. That is a significant issue that I think we want to deal with. I mean, again, from personal experience, encouraging people from diverse backgrounds really works, in that we get out of our little silos. People come with different ideas, different motivations, and that makes everything that we do, it makes everything that we do better. Anyway, so a little bit about this skills gap, and again, some personal perspectives here. Loads of good initiatives about. So we've just heard about hackathons, had some discussions about internships and competitions. So we know there's some really good stuff going on. But in most higher education institutions, there are significant challenges around more formal HPC education at both undergraduate and postgraduate level. And it varies from the excellence, and there is some absolutely fantastic provision across the country. I'm thinking particularly programs at EPCC and at Durham, which are literally world leading. But at the other end of the spectrum, most universities offer no form of high performance computing, AI education in any formal way at all. And that's really the majority. And that for us is a major issue, in that when we recruit and when those people go on to research, it's the same very small subset of institutions. And I think, I'll be a bit contentious here, the same small subset of ideas. And again, encouraging some diversity in that mix is going to be quite important. I'll mention again about the need for industry relevant skills, which does require us on the industry side to sort of step up and help bridge that gap between the theory and sort of how that theory is used to solve our customers' problems. And again, I'll qualify that a little bit, because there are some colleagues from industry who are only really interested in selling you their technology or their particular software library or application, and would love it if universities train people up on that particular application. Now, that's certainly not what we believe at Red Oak, and I think that's probably not what most people in this room would want. In a typical working career, 10, 20, 30, 40 years, technologies change, and they sometimes change overnight, and we've got to be prepared for that. So this is about equipping our future employees with the capacity to cope with change more than anything else, not about the latest buzz phrase technology that will be out of date in the sort of blink of a career's eye. So that just qualifies maybe that statement a bit. So underpinning our curriculum development strategies, I'm going to talk about two particular ideas. It's about a balance between theory and practical skills. I'm hoping for those of you involved in student education, this is all quite straightforward. To work to incorporate some industry relevant problems, to try and keep continuously updating. And I'll mention a little bit there. I was talking to Paul yesterday about, in fact, we were discussing how painful it is to write module proposals, and the pipeline to actually get a new module through a university can take 18 months to 2 years, and sometimes it's really difficult to have the right level of detail without there being too much detail in that proposal, because once that module is live in 2 years, everything you'd originally proposed is completely out of date, and you want to do something different, and you want to change your assessment, and you want to change what you teach. So there is a little bit of balance that we need there as well. That we need to be able to build in the opportunity to be flexible and to try things out, to experiment, to be a little bit playful. And in and amongst that, to think where that emphasis on an interdisciplinary approach may be, as these newer technologies appear, HPC, AI, I don't think AI is new anymore. Quantum, that's going to happen, I'm sure. Currently, in my mind, quantum goes in the same category of things as fusion, and I'm sure they'll happen together. And as long as it happens after I retire, I'm perfectly happy to have discussions around that. But again, to have a look at some real-world problems and look at problems across domains, and not just the usual culprits, not just the FEA or CFD type problems that we will classically see in HPC. It's a bigger world. There's also all sorts of interesting stuff happening in the digital humanities, in the biological and health sciences that are, again, equally as interesting to potential employees and students, and indeed to customers. And that's where, certainly at companies like Red Oak, we're beginning to see some very interesting problems coming in from industry in those domains. With any module, of course, we can teach and we can discuss and have all this really exciting and motivating content. But of course, we need to assess them, because it is a token they use as part of their degree. So having, for a module like this, some form of industry alignment is really, really important. So we're thinking things like project-based assessment here. Just heard about hackathons and competitions. Hackathons are ace. They're really good. Assessing hackathons is really hard, but as a participatory exercise, hackathons are fantastic and really help to build those softer skills, don't really like that phrase, but those softer skills that are really, really useful for those people when they go into industry. The ability to have a conversation with a customer, to talk to people, to explore with them their ideas is a key skill set that we want to encourage. Okay. Right, so two things going on. Keeping an eye on the time. Good, about 10 minutes in, I think, aren't I? Yeah. You've got a timer going. Good. So case study one is a partnership continuing with the University of Leeds, but also ACM's HPC SIG education chapter. And it is or it will be, an off-the-shelf and hopefully quite interesting 20 credit optional final year module. And the focus here is on some practical, transferable skills supported by a sound theoretical background. And the idea here is it will be a module that a non-research intensive, non-HPC university could pick up and modify for their own needs. And we are currently working with a couple of other university partners who are interested in taking this and either building elements of it into existing modules or running it as part of their own final year programme. So that's the first thing. So some of the learning outcomes, Mr. Capital L off there, some of the learning outcomes that we've got in mind are looking at how we can have complex problem solving using principles of HPC, whatever they are. Bit of vagary here. To look at where the ethical and sustainability considerations are in HPC. So I was thinking of some of the talks that we heard about yesterday, particularly around energy footprints. They are going to be key considerations of, I think, of all forms of high-end computing over the course of the next few years. And certainly thinking of some of the consultancy work that we're doing as well. We have a number of customers who are more and more interested in optimizing their codes and workflows, not for cycles anymore, but for energy use and even for their carbon footprint. So these are emerging issues that we need to consider. To look at applying industry best practices and skills. I hate that best practices word because I don't even know what it means. But whatever industry best practices are currently, and whatever the skills that are going to be useful for those young people as they move into industry, particularly communication skills and softer skills are, I think, as important as technical skills. I'm thinking as well to some of the undergraduates that I've taught in the past, particularly in computer science. They're some of the hardest skills for many computer science students to develop. It does tend to select a certain type of student who perhaps prefers the more mathematical engineering approach. But again, students that we've spoken to that have had industrial placement years, for example, come back saying, yeah, this is probably more important than the technical stuff that we're learning. The ability to talk to a customer, the ability to talk to your colleagues, to understand what we're doing, to work in a team, to solve a problem. So that communication skills element is quite important as well. So a big emphasis on perhaps the softer skills. Big practical component. And it is important, of course, to give students experience of using some form of HPC systems. So thinking again back to those universities that don't have access to HPC platforms, on-prem platforms, then we're looking at typically cloud HPC for new HPC centres as well. And that has the added benefit of being able to work with the academics who are likely to be teaching on these modules to think about how cloud and cloud HPC can support their own research as well. So we've been able to have some interesting discussions on that front too. To consider some real-world problem-solving scenarios. So we can take problems that we've got from our consultancy work and tease out some issues from them and represent those back as scenarios to students. We often find that problems are not clean, in that we're inevitably having to deal with our customers' legacy problems and technical debt problems. So we build a little bit of that in as well. One thing that we've actually tried to avoid is often the biggest problem that I think many of our industry colleagues will have with customer problems is dealing with internal politics. So we don't expose them to emulated internal politics. That just gets a little bit too painful. They're going to find that out eventually anyway. So let's take them on a gentle journey through this. And then to choose a subset of what are currently industry standard tools and practices. And I think there's an important balance here between picking the latest set of technologies, which accelerator should we choose, which set of libraries should we choose, which hardware platform should we use, and we can go and have discussions until the cows come home on that. So it's about picking something that is current, that the majority of people will have familiarity with, but understanding that in time we'll swap that out for different emerging technologies as they appear. So what the typical assessment portfolio tends to look like is a little bit like this, and I'm hoping the numbers add up because I didn't. Yeah, they do add up. Good. So very much a portfolio approach. So this builds again from some work at Leeds on a program called Curriculum Redefined, where the idea is the assessment is graded in that, or gradual, in that all students should be able to achieve a 40% pass. Okay, if you sign up to a module, you've got as far as your final year, you absolutely should not be failing. So all the learning objectives are met in that 40% part of the portfolio. And what comes beyond that is the extension that allows you to get a higher and higher module grade. So they become more difficult, and remember the old Bloom's taxonomy thing? So the 40% is down at the bottom end of that Bloom's taxonomy, and the group project, the hackathon, and that reflective journal, they're the highest level skills. The interesting thing about a model like this, and back when I was an academic, we did it on some other modules, is that we found that students actually select which parts of the portfolio to do, in that the 40% is not optional, because you've got to do that, because you've got to meet the learning objectives. But on certainly a first year programming module we did, only about 10% of students did the last bit. They avoided doing the hard bit, because students these days do tend to be quite transactional about their approach to learning. I know I want a 2-1, therefore I'm going to do this. And I think a model like this does have both the advantage and disadvantage of exposing a little bit more fully the relationship between how much work you do and what your final grade is likely to be in a module. But as it stands, that's a model that also helps to support a diversity of approach as well. Okay, so a hackathon. We're doing a hackathon as well. So this is another partnership, this time with Sheffield Hallam University, who are, again, not a particularly research-intensive university. They've got some good research groups, but I think they'd be the first to admit they're not intending to be a research-focused university. It is an undergraduate level with a STEM-focused challenge. And there's an attempt here to integrate a whole bunch of the latest buzzwords, a bit of HPC, a bit of cloud, a bit of AI, and even some quantum technologies in here as well. It's going to take place in April 2025, and it will be intended to be a regional event, so it will be open to other universities in Yorkshire and North East. And the reason I asked that question about academics, I still need some mentors if anyone's interested in volunteering. So I will be having words with people later on in the day, so don't avert your eyes when I mention mentors. So the proposed challenge looks something a little bit like this. And the reason I asked that question about a hybrid event is that our intention here is this will be both offline, online, and face-to-face. So it will take place over a few days. There will be a single day in Sheffield, the sort of get yourself together and present your findings day. But prior to that will be a sort of learning and exploration phase and a development phase for the groups. So there's quite a long lead-in. We're planning for about 10 days into this. So it takes place in April, about a week into a typical university's Easter holiday, so that they've got enough time to do that before they get a bit panicky about having to revise for their summer exams. So that's probably the best time of the year. So we've got a partnership with a public cloud provider. We're going to use their AI and quantum platform. We're going to do a little bit of AI-inspired optimization. Thank you very much. I've about 4 slides left, so I'm good. Thank you. So it's mainly AI, but we're going to add in a fairly simple quantum-inspired optimization algorithm as well. So that's the sort of stretch and challenge bit. So I think our expectation is at this stage, the quantum stuff might just blow people's minds a little bit, but for those that want to expose themselves to a different paradigm, an emerging paradigm, then this is an opportunity to do that in a sort of supportive and sort of non-threatening environment. And even if people go away from it thinking, I know this quantum thing exists, and that was really hard, and I didn't really understand the maths, but it's something I might want to have a look at in the future, then that's a win, that's a win for quite a lot of people. So what's going to be in our challenge? So typical focus, familiar AI concepts, and our experience is that students are more than likely going to be aware of these, even if they're not computer science majors. We're going to introduce some quantum ideas via a more sort of classical approach, and we're going to use what are fairly industry standard cloud resources. And if they're not standard now, they're probably going to be standard in a few years. And the idea is here that we're going to address some real-world AI optimization problems with a very, very sort of proxy hello world for quantum model. And as I mentioned a little bit earlier, the idea is that it will be a sort of scalable difficulty thing, so that there'll be an opportunity for every participant to gain a positive experience from it. Interesting, again, listening to our previous speakers about this hackathon being non-threatening and supportive. You know, we've seen too many undergraduate programs, too many hackathons that feel a little bit more like punishment beatings and competitions. You know, that's not what we want. We want people to have a positive experience about this. And even if it's hard, even if they opt out of the more technically challenging elements, every participant should still be able to come away from it feeling positive, having learned something, and having skills that they can talk about at interviews and that will take them onto the next part of their careers. So again, what are we looking at in terms of learning outcomes? So expectation to be able to analyse architecture and performance, to be able to explain some of those algorithm principles, to be able to design and hopefully implement a model selection strategy, to apply some of those cloud computing resources. And the important bit, of course, is to be able to evaluate the effectiveness of all of this. So it's like the full life cycle of quite a tightly constrained problem.
Real quick question.
Go on.
Are these going to be individuals in this? Is this going to be individuals
Group.
in this hackathon or teams?
Teams.
Teams.
Yeah. So again, it's a good question. I mean, coming back to that that issue about diversity and support, something like this would probably be too challenging for, I think, for most individuals, you know. But whereas, you know, a team of 5 or 6 like-minded people, you know, there's enough of a difference of opinion, a difference of skill set there to be able to cope with that. And again, referring back to what I said earlier on, that ability to understand how to work in teams, and I think understand how teams work in industry is really important. I'm sure many of you involved in student education, you will have had nothing but complaints from students about teamwork, right? They hate it. Okay, absolutely despise working in teams, and mainly because it's always 1 or 2 people who end up doing all of the work, all right? And that happens at undergrad level. However, when those people move into their industry jobs, they have no option but to work in interdependence, interdisciplinary teams. So there's perhaps another conversation to be had there about, you know, how we can help make that process better. But I think the interesting thing is they come from hating working in teams and not being able to do it, and then a year later they're fine. You know, I mean, maybe there is a difference. Maybe they're getting paid for it. Maybe that makes the difference. There we go. And maybe you've got a boss that won't pay you if you don't do it. So maybe there is a bit of an incentive there. Okay, so in terms of a bit of a recap then. Certainly when I was an academic, I can honestly say thank you. I might be on time actually, that's good. I think it is hard. It is hard to build relationships with people in industry. It's also hard for people in industry to be able to change their mindset to understand how education works. And there's definitely a mismatch between the two. But industry really does need people that have some real world experiences. And I think more than anything else, what we want to see is people who are enthusiastic. So we certainly wouldn't expect universities to prepare people who are fully equipped employees at 21 or 22. Absolutely not going to happen. But to have people who are enthusiastic, who are willing to learn, who don't mind making mistakes, because goodness me, we make a lot of mistakes. And I think not only being able to make mistakes, but to be able to recover from them and learn from them is an incredibly important set of skills. And encouraging this continued partnership between industry and academia sort of ends up helping us all, really. Probably what a lot of people in academia may not be aware of is there is as much research that goes on in SMEs and larger industry concerns, as happens in universities, but we just don't publish it, right? Often because we can't publish it. But there's some really, really interesting work going on there. So in being able to have those conversations with colleagues from industry to find out what they're doing as well, I think would be an interesting thing for many people to learn from. I forgot. Yeah, no, there is one more slide. Okay, so as a bit of a recap then, so obviously change is constant. I don't think I'm telling anybody anything surprising there. But as a community, I think we need to try and embrace change more. And I think there are perhaps sometimes in this community, and I've been a member of this community for quite a while, so I think I can say this, there's a tendency towards Ludditism sometimes. And I think it is hard if you've worked in a particular technology, in a particular framework for very many years. Sometimes the pace of change is difficult to cope with, but that's the skill set that we want employees to have, and perhaps we need to model some of that behaviour ourselves. We need to try and keep not ahead of the curve, we're never going to do that. On the curve, on the crest of the wave is fine. To identify what those emerging trends are going to be and how we incorporate them. How we incorporate them in teaching, but how we incorporate them in problem solving as well. And to try and work in partnership with industry to understand what a curriculum might look like, what a high quality curriculum might look like. And I think what that naturally leads on to is continuous professional development as well. And that's something else I can wax lyrical about, but I won't because I've only got about a minute left. And I think that works both ways as well, that these partnerships can help in CPD for both industry professionals and for academics. And I think there is going to be this convergence. Hopefully it's in about 4 years' time when I've retired, of HPC, quantum and AI. And I think that's something that we need to try and prepare for. So that was me. So just a few things that we're doing at Red Oak. Love to have extra conversations with people about this. We'll be looking for mentors and people to have conversations with, and as we build out the curriculum, to have some more conversations with people about some little case studies and interviews and things like that. So watch this space. Thank you very much. Am I on time? There we go.
Do we have any questions?
Hi, just a couple of points on that, filling that funnel of skills coming in. I'd encourage everybody to register on inspiringthefuture.org.
Definitely.
Because basically you put your details on there and teachers in your local area can invite you into schools. And I've done careers talks at Leicester College, and I've also done the scariest thing, which is a primary school assembly. We're doing jobs that these kids have never heard of.
Yeah.
So actually getting that thought process in early. And I think the other point is that it's great from a university point of view, but there's an awful lot of skills needed that are not
sub-degree level skills. Absolutely. Yeah.
I mean, I was working at Sixtera when we put the first 3 quantum computers into a commercial data centre, and the plant guys having to get the chemistry set out to work out how to get liquid nitrogen and 2 isotopes of helium into the middle of a commercial data centre and reach absolute zero was quite a feat. But at 55, I've been selling machine learning and AI systems for 10 years. I've just retrained as an ethics and compliance consultant because I've hit the wrong side of the DEI.
Things change, don't they?
Yes, so you just need to move
change
with
is
the times.
Constant. Yeah. Thank you.
Thanks, Martin. What are your views on kind of levels of assessment? Because one of the slides you showed there had kind of like 5 different types of assessment within a kind of potential module. I know I'd have got a huge amount of pushback for kind of trying to introduce 5 different methods of assessment within, say, like a single module.
So right,
There's an increased push towards things like program level approach.
Yeah. So there is. So in this particular module, the idea is to offer some options, and the final set of options that be selected are obviously part of that programmatic approach. Now, Leeds went through a program called Curriculum Redefined because in many programs, what had happened is that a programmatic approach to assessment had been completely died years ago. And certainly in computer science, there were umpteen 10-credit modules, each with their own model of assessment, where it was very clear there had been no conversation across years or across the programme to have a holistic view of assessment. I ended up being academic assessment manager in the School of Computing, which might also tell you why I left and went to industry, but that's another story for another day. So yeah, a programmatic approach is important. So this, I think we should think about not thinking about modules in isolation, but thinking about modules as part of a whole. What becomes a little bit more difficult but interesting is that there are certainly elements of assessment in there that can be assessed across modules. Yeah, like the journal, for example, a reflective journal for final year students as a sort of high-level differentiator is a really interesting model to consider. They are hard to do, and often you find that a lot of people, you know, you've been teaching a module for 10 years, you're very possessive of that and you don't necessarily want to change. But talk to students, in fact we've only got one student in the room, unfortunately. Often the assessment burden on students is enormous, and you know, that term punishment beating actually came from a final year student. Assessment on this degree feels more like a punishment beating than me actually learning anything. So it can be a challenge, but actually massively reducing the amount of formal assessment that we do can be hugely liberating, both for academics who then no longer have to mark the bloody stuff, which is a soul-destroying experience, but also for students as well who then have the space to learn rather than be assessed. So there we go.
Thank you, Martin.